Okay, in this video we'll be focusing on question 2 of Physical Sciences paper 2 November 2022. So we are given the table below. So on question 2.1.1 they said write down the letters that represent two organic compounds that are isomers of each other. So we know that the isomers have the same molecular formula but a different structural formulae. Now, in this case, that tells us that the number of hydrogens and the number of carbon must be the same. So in this case, that will be our C and D. When you look at C and D, they look exactly the same. We have the same number of carbon and the same number of hydrogens. So we know that these are our isomers. So we say C and D. Okay. We move to 2.1.2. The type of isomer, chain, functional or positional, identified in question 2.1. They want to know the type of isomers. Remember, if it's a chain isomer, that means they differ in chain. If it's a functional isomer, it tells us that they differ in the functional groups. If it's a positional isomer, it tells us that they differ in the position of could be the functional group and so on. So it could be the carbonyl, so or rather the double bond or triple bond. So in this case, because if I look at C, when you look at C, we have the carbonyl group that is attached to carbon and the hydrogen. When you look at it nicely, let me draw it that way. When you look at C, we have something like this, right? Which makes it a C to be an aldehyde. Now, if you look at the D, we have the carbonyl group that is attached to two carbon atoms, which makes D to be a ketone. So can you see, even though they have the same number of carbon and the same number of hydrogens, but the functional group differs. This is an aldehyde and that is a ketone. So because they differ in the functional group, so those two are the functional isomers. So the correct answer will be functional. Okay, we go to 2.1.3. The general formula of the homologous series to which compound B belongs. Compound B. Okay. So the compound B is alkyne. So we know that the functional group for the alkynes, it will be C2. It will be C2H2N minus a 2, because they've said the general formula. So the general formula will be C2H2N3. Okay. We quickly move to 2.1.4. Name the functional group of compound F. Name the functional group. Where does F belongs? We know that F is an alcohol, and we identify the alcohols by they belong to the hydroxyl group. So they belong to hydroxyl group. So hydroxyl. Okay. We quickly move to 2.2. On A, 2.2.1 said we should write down the IUPAC name of compound A. What is compound A? So we number the longest chain. So we start closer to the halogen. So we say in this case, this is our longest chain. 1, 2, 3, 4, 5. 5. If we go this way, if we go in red, manage to get a 5. So let me check if it's possible that I would get something that is more than a 5. Okay, let's see. We again, let me so we have 1 2 3 4 5. So this is also 5. Okay, and again, let's check. 1 2 3 4 5 6. So we have the longest chain that goes that way. So now remember, we number from the halogen. That means once you are required to name, it's better to start by pulling out what is there on the chain. Like for instance, on position number 2, on position number 3, we have the bromine. So I'll just say bromo on position number 3, and on position number 4. Remember, it's 1 2 3 4. When we get here to 4, I see the side chain of methyl, the 2 methyl attached to position number 4. So I will say 4,4 dimethyl, right? Because we have 2 methyl group on position number 4. So we say it's 4,4 dimethyl. Okay. Then from there we have everything. We've pulled out everything. We start by writing the parent chain. So remember, when you write these, we follow the alphabetical order. So B comes first. So we have 3 bromo, 4,4 dimethyl hexane. The longest chain had 6 carbons, so which makes it hexane. On position number 4, there are 2 methyl groups, so we said 4,4 dimethyl. On position number 3, we had the halogen, which is bromine. That's why we said bromo. Okay, we go to 2.2. Compound B. We need to write the IUPAC name of compound B. Okay, compound B, we do the same thing. Even here on B, do the same process. Okay, so we number the longest chain. We have 1 2 3, but in this case you should count starting closer to the triple bond. So I think, okay, let's check the longest chain. So the longest chain here will be 1 2 3 4 5. So the longest chain will be 5. Okay, so looking at that longest chain, now we have on position number 2, I have 2. On number 2, I have the triple bond. So we say it ends with Y. So on position number 4, I have a 2 methyl group. So it's 4,4 dimethyl. Then we are done. We can write everything now. So the name for B will be 4,4 dimethyl. The longest chain is has 5, which is pentane. So we're going to have a pent. Because of the triple bond, we say pent. Then we also include that is 2 wine. Okay, that is our 2.2. We go to 2.3. Compound C. Compound C is an aldehyde. The aldehydes we don't stress much because we know that the carbonyl group will always be at the end. You just count the number of your carbons. 1 2 3 4. The name ends with Al. 1, 2, 3, 4. So 4 carbons, it should be butanal. We have butanal. Should be butanal. So we are done with that. Then we go to 2.3. Said compound F reacts with a carboxylic acid to form compound S in the placement of a strong acid. Okay, so compound F, which is an alcohol, this alcohol reacts with a carboxylic acid. We know that when the alcohol reacts with a carboxylic acid, the type of reaction is esterification. So so we go to our questions on 2.3.1. Write down the type of reaction that takes place. We have mentioned that whenever an alcohol reacts with carboxylic acid in the presence of that an acid, the process is called esterification. Okay, so we are done with that one. So this is esterification. Okay, so we go to the last question. On the last question, they've said we are told that compound S has the empirical formula of, let me quickly erase. Okay, so we are told that compound S has an empirical formula. Here is compound S. Remember, compound S is an ester which was formed when that compound F reacts with that carboxylic acid to form compound S. Now this compound S has the empirical formula. It has the empirical formula which is C3H6O, and it has the molar mass of 116 grams per mole. Okay, so the question said write down the molecular formula of the carboxylic acid. We know that this compound S is formed using the acid plus alcohol. So if we need the empirical formula for the molecular formula for the carboxylic acid, we can start by finding the molecular formula of this compound S. So we start by finding the molecular formula of compound S. So to do that, we can now find the molecular formula of this one. The molar mass of this one using the periodic table. So we know that we have 3. Our carbon on the periodic table will be is 12. So plus the hydrogen is we have 6 hydrogens, and on the periodic table the molar mass is 1 plus oxygen is 16. So when you punch this, we get we say 3 times 12 plus 6 times 1 plus 16. That will be 58. Okay, then with that one, 58 grams per mole. Okay, then from there we take this molar mass, we divide it by 58. The answer that we get, we multiply the empirical formula, we'll get the molecular formula of compound S. So now we have 116 divided by 58. That would give us we say 116 divided by 58, we get a 2. You take this 2, you multiply the empirical formula. So you say 3 times 2, we have 6 here. Again, you say 6 times 2, we get a 12. say a 1, there's a invisible 1 there. 1 times 2, we get a 2. This is the molecular formula of compound S. But the question said we should find the molecular formula of carboxylic acid. Therefore, we need to remove the alcohol that we had here. We remove the alcohol from this molecular formula of compound S and the water formed. Remember, with this and ester, when this carboxylic acid react with the alcohol, and ester, which is this one, compound S, and water will be formed. So we remove all this alcohol and water from that. So the correct answer will be C. It will be we'll have C2H4O2. Okay.